Hello, everyone. A couple years ago, I decided I wanted to look into putting solar panels on our house, and I was wholly dissatisfied with the amount of information available for particular parts of the process, particularly sizing and designing the system, financing, performance predictions, things like that. So, having gone through the process, I decided to put together a bunch of notes on what my experience has been and share them with everyone. So, hopefully, these are helpful and informative for you moving forward. So the first thing that you need to do when determining whether or not you want to put solar panels on your house is size the system. And there's a few questions you have to answer before you get started. One of them is, what is your usage? For most people, this is as easy as logging into your account for your energy supplier, in this case DP&L, and downloading what your monthly or annual usage is. For the most part, you only really need the annual one. Depending upon your net metering laws, though, you may want to know what your monthly usage is as well. For us, it's about 1,700 kilowatt hours a year. Another question that I had that took a while to find the answer to is, how much do direction and tilt matter? Everybody knows that you're supposed to point them towards the south, but how much does it really matter? And there's a great paper published by Craig and Greg in 2001 that does a really good job at explaining the percent degradation based on tilt and direction. So for us, we're oriented almost perfectly north-south on our house. So the back of our roof faces almost directly south. It's off by 11 degrees. And we have an 812 pitch on our roof, so it's about 38 degrees. So marking that based on our location, which is Southwest Ohio, we're getting about, 97, 98% of, the theoretical potential out of the panel. So that was pretty good in our mind. No need for any sun tracking system or mounting them at an angle or anything like that. In general, uh, pretty much any tilt is okay, right? Anything from 0 up to, 40, 50 degrees is fine, which is a pretty steep roof. And as far as azimuth, pretty much anything plus or minus, 40, 50 degrees from south is pretty decent. So in general, if you have a south facing roof, you're fine. Don't worry about it. So where you are in the country makes a really big difference as far as how much solar radiation your house gets. There are lots of different databases. All of them will give you slightly different numbers just because of their data was taken at any given year, and that year may have been, particularly sunny or not. The three that I looked at most often was PV watts, which is a National Renewable Energy one, the NSRD, which is the National Solar Radiation Database, and then Google has its own as well. Of the three, I prefer the one that PV Watts uses, and we'll get into why later. So for Southwest Ohio, we get roughly 4 kilowatt hours per meter squared per day, which is not too bad. If you go down to like the southern parts of Arizona and New Mexico, you can almost double that. So system layout. One of the online resources that I used is Project Sunroof from Google. It is very simple. It's all automated. You just type in your address and it gives you this, map of your house. You tell it what your monthly electric bill is. For me, it's about 150 bucks, and it does everything else automatically, which is both good and bad. One, good because it's easy, bad because there is no customization whatsoever. I have no idea where it's placing the panels, what it decided it thought the pitch of my roof was, what type of panels it's using. I have no idea how it knows how much I'm paying per kilowatt hour for electric. It's just, they say 12 and a half kilowatts, and that's all you really have to go on. So I didn't particularly like this tool, but what I did like it for was it gives you this map of your house that shows you what are the areas that are best suited for solar panels. So from shady to sunny. I reached out to Google asking what shady and sunny meant and did not get an answer, but that's fine. You can use it, you know, qualitatively. So I know what panels I want, these Aptos, 370 panels, and I can take dimensions of my roof and I can start to lay out where all those panels go. There's a whole bunch of rules that you have to follow for layout. It has to be 18 inches from the ridge on both sides. You have to have a 3-foot wide path from eave to ridge on every roof plane, unless, of course, there's caveats. It's less than 33% of the roof area. The structure is not connected and uninhabited, or the fire chief agrees that no rooftop operations are expected. So I did reach out to my city and talk to the fire chief. And because we were only putting panels on the back, and because our roof is pitched high enough that they're probably not going to be doing roof operations in general, I was able to get the fire lane essentially waived for their garage. And they did allow me to put them on the garage, even though it is connected. So that was great. And I ended up with 31 panels for 11.47 kilowatts. So PV Watts, this is the one, the online tool that I liked better, and it's produced by Enro. Starts out very similar. You just put in your address, and then it takes you to this page that you can customize. So you put in what size system you want, in this case 11.47. The panel type for most people is premium. The array type is just fixed on my roof. We'll do system losses here in a second. Tilt 33.7 and azimuth 169. Each one of these information radio buttons on the right will give you a pop-up window that explains what exactly that category is. So for tilt, for example, there's a table that tells you 812 is 33.7. So you don't have to do any math. For the system losses, there's a whole bunch of things that will cause your system to reduce in efficiency. I left all of these numbers as the default values except for shading. Based on the map that I got from Google, where the panels are going, and the fact that I know I have a tree in the backyard, I estimated that about half of the panels are going to be in the shade about half of the day. So I increased the shading percent to 25%. And then you click go, and PV Watts gives you this estimated performance for your system. If you have multiple roof planes, you just break it up into individual roof planes and it'll do each one individually. So in this case, it is projecting I'm going to do about 11.9 megawatt hours per year. So you can graph this, and you can see all the way on the right that I'm going to be producing, according to PV Watts, about $4 of electric per day. You compare it to my usage, and you can see that in the spring and the fall, I'm potentially maybe going to be producing more than I use, but in the summer and winter, I'm going to be using a lot more than I produce. And I know that the system is undersized because we only wanted to put panels on the back. One thing that you do have to be cognizant of, though, depending upon the net metering laws in your area, these regions of greater or less than production may become important. For Ohio, it's 1-to-1. Every kilowatt hour that I push out to the grid, I get back. So it doesn't matter so much for Ohio, so long as the average works out, or the annual production works out. In some states, particularly the Southwest, there's net metering laws that are a little bit more stringent, so this might be a little different for you. But for me, it didn't really matter. So financing. So one of the mistakes that I made is when I started, the first thing I did was reach out to a bunch of companies and ask for quotes and designs and what they would do. And as you could imagine, I got very wildly different quotes. Right, everything from a 5 kilowatt system all the way up to a 13 kilowatt system, and everybody had different ideas about whether or not I should put them on the dormer, whether or not I should put them on the garage, whether or not I should put them on the breezeway, where they would go, what size panel and orientation and the arrangement. There was no uniformity at all between any of the different companies. The other thing that I found interesting was I got a extremely low interest rate from, I believe it was Moxie. All of the full service installers include financing or you have the option to include financing as well. And I told the others, that I got this great rate from Moxie, and Solar is Freedom matched it, which was really nice. But this wasn't very useful for me because none of these really matched what I wanted to do after I went back and did the research and found out what I wanted. So I scaled everything just dollar per kilowatt hour to an 11.5 kilowatt system and got this. So the DIY companies, so Unbound Solar and Go Green Solar, do not have financing themselves. So I had to go out and find my own financing, which is fine, but it's just another task for you to do. The two criteria that we had for the financing piece was that we wanted to be done within 15 years, just because of how long we plan on staying in the house. And with a 15-year loan, we wanted our monthly cash flow to be positive. We didn't want our electric bill to essentially go up because of putting in solar panels. So as you can imagine, you could guess, which way we went. The important thing though is looking at the bottom row, which is the break-even year that we calculated. Some of the full service ones have pretty long break-even points, upwards of 20 years. And the panels are only guaranteed for 25, should last about 35, but having a break-even point at 20 is pretty far. So we did choose to do it ourselves. We went with Unbound Solar. For financing, Figure.com easily gave us the best terms and rates. We ended up just paying for them out of pocket and not actually going with a loan at all. But if we had gone with a loan, I would have gone with Figure. And if we had gone with a full service company, I would have gone with either Solar is Freedom or Third Sun Solar. So how much did it cost? Safety and equipment, I had to buy some harnesses, pulleys, ropes, a couple roof anchors, things like that, about 190 bucks. General supplies beyond the kit, just a little bit, nails, tape, zip ties, things like that, very small things. Permits and inspections, you need both an electrical and a structural permit. That was about 150 bucks, and the inspectors were quite helpful. The electrical inspector in particular came out at least 2 or 3 times prior to me even doing anything, and we had several discussions about where to put things, how to connect different pieces, different things I needed to look out for, and things like that. The utility interconnection, about 130 bucks. So you have to have a bidirectional meter, which most people don't, if you're going to have a grid-tied system, which this is. The entire process took about a month. And before you can start it, you need to know everything about the system you're going to install. So the inverter models, the size of the system, the type of panels that you're going to be putting on, everything like that. So you can't start this until after you get your design back from engineering. Labor, of course, was zero. The kit itself was about $19,000. And then there's a federal tax credit for 30% through 2032, which is great, which includes batteries, interconnection, pretty much anything that is used, in the installation wholly, you can include for the federal tax credit. And then an extra 10% if anything is made in the US. So grand total, a little bit south of 14 grand for an 11.5 kilowatt system. So one of my complaints in working with the full service installers, all of them were extremely rosy, I'll say, in their predictions about performance. Once you start asking questions and you really dig into the data, several of them were quoting 6, 8, 10% inflation rates on my energy bill when calculating break-even points. And for Southwest Ohio, for the past 30 years, it's been about 2.5%. And just many egregious things like that. And zero of them talked about disposition, right? If one of the panels fails or they at the end of their life, you can't just throw them away. There's a cost for disposing of or recycling them. And that ends up being, 2 to 4 years of production value, which is not insignificant. So installation. This part I'm going to keep a little bit short, just because I know there are several other videos and people talking about how to install them and everything. One of the things that Unbound Solar prides itself on is it advertises that it gives you absolutely everything you need, right down to the socket for installing everything. And it was pretty close. They did a pretty good job. This is a list of everything that was in my kit that was sent. The things highlighted in red, the deck mount kit, that was for mounting the conduit on the roof. I ended up just attaching it directly to the rails, so I didn't use those, which I thought was cleaner. There was a 4-inch junction box, which I have no idea what it was for, so I didn't use it. The plastic zip ties, they gave us a bag of 100. I used probably closer to 200, so I had to buy a bag of zip ties, not a big deal. They gave me a lumber crane, which I did not use. The concrete drill bit didn't even make it through one hole, so I just used one that I had already. And then the 1/4-inch wood drill bit was a good bit, drilled about 100 holes, but I needed about 150, so I ended up buying another one of those myself. So pretty close to everything you needed. So tools and safety equipment, again, for personal tools wise, I had to buy a bit. That's about it. Everything else I had. Everything you see here is what I used. Not all of it I would use again. Some things like a reciprocating saw for cutting off the rails I really didn't like. I ended up using a circular saw and a cutoff blade, which made a much nicer cut. But these are all the things that I did use. As far as safety equipment, I had to buy everything. I think most of it came from Amazon. $190, would definitely do that again. And then supplies, all I had to buy again was the zip ties, the split bolt connector, and roof cement. So when you get it, it comes via freight. The guy had an electric hand jack, parked the pallet directly in my garage. Couldn't have been easier. Unpacked everything, and this is what everything looked like. First thing you do is obviously make sure everything was there. I had 2 issues. One is I was missing one trunk cable for connecting the panels. Somebody just miscounted. And the disconnect box was missing one of the terminals for one of the lines. So I took a picture of it, called Unbound Solar, got forwarded to the warehouse manager, texted him a picture of the box so he knew what I was talking about as far as the connector. 5-minute conversation. 2 days later, everything showed up in the mail. Great customer service. Would highly recommend them. So the actual installation, some of the things that I did here that worked out really well. I built a peak shelf. So you'll see it right there, just a scrap piece of plywood with a couple legs on it. That worked fantastic for holding things while I was on the roof. Sitting anything down, it just fell off. The rope and rigging system I used worked really well. So, peak anchors on either end, a rope in between them with a rope in the middle, a traveler pulley, and an ascender. That worked great because my roof is an 812 pitch. If yours is like a 412 or lower, you probably don't need to worry about it. Lining up the rails took some time, right? So running strings in between them, make sure everything was flat. Still didn't get it perfect, but close enough. It doesn't look too bad. The lumber crayon that the company gave me was this, bright orange, wax crayon. I could not find online a good resource on how long the marks would stay on the roof. And I really didn't want these fluorescent yellow crayon marks on my roof for, years. So I ended up just using chalk, just a old-fashioned stick of chalk. There were a few times that, I had to remeasure some things because the mark kind of disappeared a little bit, but I'd much rather do that than have crayon marks on my roof forever. I did see online a couple people suggest using a stud finder to find your rafters. I tried to do this, but I have an older house with 1x6 planking on the roof, and it just didn't work. The instructions from Unbound Solar are to use a hammer, but we just replaced our roof and I wasn't too excited about beating on the shingles with a hammer. So I ended up just measuring everything, and that worked fairly well. All the rafters are a standard, distance apart, so I just measured from the edge, and 75% of the time hit the rafter on the first try. All of these legs have to be sealed and flashed, but Unbound gave you all the roof cement and everything that you needed to do it. It was very simple to do, just time consuming, running up and down the roof. I did everything by myself. I had no help at all. The entire process took about 10 days. So I took a week off work, and in those, 9 days, I got almost the entire thing done, which I was pretty happy with. The only place where I do wish I had an extra set of hands was placing the panels themselves. It was difficult to hold the panel in place and try to connect the wires and zip tie them out of the way, so they weren't touching the roof, while also trying to, screw them down to the rails and make sure everything was lined up correctly, and things like that. So an extra set of hands actually placing the panels would have been helpful. For everything else, one person is just fine. The other thing that I built, that you've seen already, you'll see again here in a minute, is a stand to put the panels on. So it looks like a big H, just a couple 2x4s with a 2x6 in the middle. So on the ground, I get the panel ready, uh, lift it up onto this rack, climb up onto the roof, and then lift it up the rest of the way. And that worked out really well. The flexible conduit that you can see coming off the roof right now, this stuff is horrible. I really wish they would have given me just, you know, metal galvanized pipe, and I could have rented a pipe bender, and it would have been a much better solution. The problem I had with this is, one, it doesn't look very nice. I don't like how it looks, and it's really difficult to fish wire through it, because it's essentially plastic. So whenever you get more than about 3 or 4 wires bundled together trying to push it through this conduit, it gets stuck, and you can only do about 10 feet at a time. So I ended up having to cut the conduit that comes off the roof into 2 pieces and then splice it after I had run all the cables through it. So not a big fan of that. I tried everything I could think of, and nothing seemed to work to get the conduit through. It was really hot, so I do suggest a hat and lots of water. The hat came in handy in particular. There was at least one bird that did not appreciate what I was doing, and made his opinion known. And I did melt the soles off of a pair of shoes doing this. There were a couple days in in 90 degrees where the roof was about 120, 130 degrees. It got really warm. You'll notice that the panels are going pretty close to the edge of the roof. That was by design. So they're about 6, 8 inches away from the dormer there, and they run all the way out to the edge. I got that approved from the city. They were fine with that. And for the most part, it wasn't too bad. There were only a couple spots where I had to, lay down and really reach, to get the attachments the way I needed them to go. But for the most part, everything worked out fairly well. So these are the last few panels I'm doing here. The easiest obviously was the dormer and getting the panels on top of the dormer. So the last part was collecting everything and bringing it down into the combiner panel, the cutoff switch, and then attaching it to the main breaker. One thing that you do have to do is you have to label the combiner panel with each individual string. So you have to keep track of the strings as they come off the roof. I have 3 strings, so you can have no more than 12 panels per string. So what I did was I wrapped a single loop of electrical tape around string 1, 2 wraps around string 2, and then 3 around string 3. So after I fished them through the conduit, I knew where everything was. One of the other things that I couldn't find online very readily was a good picture of the combiner box, which I'm showing here. The electrical diagram that I got from Unbound Solar was a one-line diagram. So it shows you what is connected with what, but it doesn't give you the individual wires and how to connect, individual wires. So that's the purpose of this. One discussion I did have with the electrical inspector is using the neutral bar as the grounding bar, and that was fine. They do sell a ground bar kit for this, but I didn't see the need having a neutral bar already installed. You just have to install the green grounding screw. Other than that, just remember to keep track of the strings and red on the right, and you're good to go. So after you label everything, you move over to the cutoff switch, again, right on the right. Nothing too exciting, but you can see the lug there on the bottom, the screw terminal connector that I was missing. And then the last bit is connecting it to your main breaker panel. For me, the main panel is outside, and then I have a sub panel inside. This is where the split bolt connector suggestion from the electrical inspector really helped out, because I don't have any open ports on my grounding bar. And then came with a kit, these insulated piercing connectors, which are designed specifically for this, for connecting to the main line without having to turn off the power, which was great. So I did this myself. I just wore a pair of insulated welding gloves, and it was fine. It took 5 minutes, had no issues whatsoever. And the last thing you got to do is just label everything. And then there's a whole bunch of signs, letting first responders know that you have, parallel generation on site. One thing that you do not want to forget to do is take pictures. You have to take pictures of every single panel installed on the roof. You'll need that later when you register the system for doing solar renewable energy credits, or SRECs. So this is what they look like on the roof. So SRECs, solar renewable energy credits. So this is mostly in the Northeast, and what this is it's a program, government-run program, to incentivize energy generators, power companies, to use solar. If the power company doesn't own renewable energy sources themselves, they have the ability to buy credits from other sources, to include homeowners that have solar panels on their roofs. Depending upon where you live, this can actually be fairly lucrative. If you live in the DC proper, there at the time was trading $285 per credit. So a 15 megawatt system, which is just a little bit bigger than what I'm doing, you can make about $4 grand a year just in credits, and the system will pay for itself in 3.5 years. Not too bad. In Ohio, where I live, they're currently trading for about $5 a piece. Not the greatest, but I am allowed to register in Pennsylvania on the PA Tier 1 system, where they're trading for about 20 bucks a piece, and that's what I ended up doing. So it's fairly simple. You just go to the Pennsylvania Alternative Energy Credit Program website, and it'll step you through the process of registering and getting everything set up. First thing you do is just register with the PA Alternative Energy Credit Program. You have to give it all of your system specs. So the size, the inverter type, you have to submit pictures of all of your panels and everything else, and they will certify you that you are a accredited generator of renewable electric. That process took about a week, right after I emailed everything in. So not too bad. So you get an email that has your PA state certification number, and then you can take that and go register with a attribute tracking system. There are several different ones. GATS is the one that I used in this case. Fairly straightforward. You just register for an account, and then once you are approved, every month you input what your generation is, and it keeps track of it. And once you hit a total of a megawatt, it will mint a SREC, or generate a credit for you, and keep track of it. And then whenever you want to transfer or sell those, there are guides online that teach you how to transfer your credits to other people. Fairly simple. So after you have minted credits, you then have to sign up for an exchange so you can sell them. Flet is one of the more popular ones. There are others. Flet is the one that I went with. On their website, they give you, per day what everything is trading at. PA Class 1s trade at the same rate that New Jersey Class 1s do. So you just look up the New Jersey price, which is in this case $22, and that's what you get for your SREC. The first time I did this, I transferred 5 credits to the Flet exchange, or sold 5 credits. They were $22 each. Flet charges $2.50 for processing, and then another 50 cents per SREC. So $5, and I got $105. Those 5 credits represent about 5 or 6 months of generation for me over the winter. You can either get a check in the mail, or they'll direct deposit the money into your account. So it just showed up one day, $105. Fairly simple. In the future, I plan on doing this probably once a year. Not worry about it. Just do all 12 months, input all at the same time. A day later, you'll get your SRECs, and then you can transfer them to Flet and be done with it. So what you've all been waiting for, performance. How did the system do relative to what we thought it would do in the beginning? So every system on the market comes with an app, so you can track performance. Mine looks like this. They're all very similar, I'm sure. So you can see system performance, on a clear day, on a partly cloudy day, on a very cloudy day. This is extremely addicting for the first couple months of having the system. I looked at it multiple times a day. You can look at how much power you're generating right now, how much you've generated for the day. You can look at individual panels to make sure each one is operating properly. You can actually watch as the sun moves across the sky and the shadow of the tree moves across the garage. You can watch the shadow move across the panels. It's very addicting. And then you can look at, obviously, your daily production, monthly, yearly production as well. And this app is how you get the numbers that you input into the GAT system for registering how many kilowatt hours of production you've had. You can also use your meter readings, but I found this to be easier. So the green line is the predicted PV watts, what the usage was, or the production was predicted. The red line is our usage, and the blue line then is what we actually produced. So not too far off from what PV watts predicted. We're about, I think, about 10% under. So not too bad. You do also have to remember that, this is a single year. So over an average, it might get a little better, it might get a little worse. But in general, it's pretty close. So my annual production over the past year, a little less than 11 megawatt hours, which saved me about $1,200 in electric. And my break-even point is going to be about 11 years and 9 months. The system I would need if I wanted to completely eliminate my electric bill is about 18 kilowatts. We're not interested in that just because we don't want to put panels on the front of the house. And the fraction PV watts obviously is 9%, so it's about 10% lower than what PV watts predict. So that's it. I hope that was helpful. Let me know if you have any questions or comments, and have a great day. Thanks.